Hi everyone, Assalamualaikum. In this video, we will continue with example 2 under total differentials. This example from previous semester papers. Use total differentials to approximate the value of f 1.10, 1.98 if fxy equals to ln square root of 1 plus xy. Give the answer correct to 3 decimal places. Right? Step 1, we need to identify x, x naught dx and y, y naught dy. Okay, we recall back x equals to the given decimal numbers for x. Okay, right, from here x equals to 1.10. Okay, x equals to the nearest whole numbers for x. The nearest whole number for 1.1 equals to 1. So this is the value for x naught. Okay. Then we need to find dx. dx equals to x minus x naught, means 1.1 minus 1 equals to positive 0.1. Okay. After that, we need to find y, y naught, and dy. Y equals to the given decimal number. Okay, so y, in this case, y equals to 1.98. Y naught equals to the nearest whole numbers for y. Means the nearest whole number for 1.98 equals to 2. So means that y naught equals to 2. After that, we need to find dy. dy equals to y minus y naught. Okay, so 1.98 minus 2 equals to negative 0.02. Okay. Then step 2, find the function of fxy and the value of fx naught y naught. Alright, we are given fxy, which is equals to ln square root of 1 plus xy. Okay, then we can find fx naught. Okay, x naught means 1. Okay, y naught equals to 2. Means we want to find the value of f12. So we substitute 1 into variable x and we substitute 2 into variable y. So we get this. Okay, then we simplify, so we get ln sert 3. Okay, we leave fx naught y naught in ln. Do not leave it in decimal for more precise approximation. Right? Alright, after we done find fx naught y naught, then we can continue with step 3. Find fx and fy and its value at x naught y naught. Okay, so we can find fx from f. Okay, alright, from f here we have ln and then sert. So to easy differentiate, we can write sert into the form of bracket to the power of half using the properties of indices. Okay, and then from properties of log, we can move power to the front. Okay, from log am to the power of p. So when we use logarithmic rule, so we get 1 over 2 means p log am. Okay, means half ln 1 plus yx. Okay, now we want to find fx. Fx means partial derivative of f with respect to x. We treat x as a variable. So to avoid error and easy to differentiate, we can write x in different color and we put variable x at the back. Okay, and at the same time we treat y as a constant. Okay, so from here we have half here. Half means constant. Okay, and then multiply by ln. Okay, with variable x. Okay, so when we differentiate y with respect to x, we get fx. and we get this. Okay. Now we have multiplication between constant and function with variable. Okay, in this case variable x. Okay, because we treat x as variable when we find fx. So if we have multiplication between constant and variable, we just keep the constant in front and then we differentiate the function with variable here. The function here means ln. Okay, so to differentiate ln 1 plus yx, we just imagine. Let's say we want to differentiate ln 1 plus, we replace y constant by 2. Okay, so we have 2x here. So to differentiate ln 1 plus 2x with respect to x, we get 1 over 1 plus 2x. After that, we need to multiply by the derivative of the function in ln. So we differentiate 1, it is equals to 0. Plus, we differentiate 2x equals to 2. Okay? So same goes to derivative of ln 1 plus yx. So after we differentiate ln here, so we get 1 over 1 plus yx or xy here. Okay, from this, if we want to differentiate ln 1 plus 2x, we get 1 over 1 plus 2x. Means, if we differentiate ln 1 plus yx, we get 1 over 1 plus yx or xy. Okay, and then times, from here, we differentiate in bracket, in ln. So we get 0 plus 2. And then same goes to here. Okay, we differentiate 1, it becomes 0. And then we differentiate constant and then x, so we get constant. Okay, we imagine y equals to 2. So we get 2. When we differentiate to x, we get 2. So when we differentiate yx, we get y here. Okay. Right. After that, we simplify. So we get y over 2 and then times 1 plus xy. Then we can find the value of fx at x naught, y naught. Okay, our x naught equals to 1 and y naught equals to 2. Then we find fx equals to half. Okay, fx equals to y over 2. So y we replace by 2 and then over 2 times 1 plus x we replace by 1 and then y we replace by 2. Then we simplify, so we get fx equals to 1 over 3. Right? We leave fx in fraction. Do not leave it in decimal for more precise approximation. Okay? From the previous slide, we get fx equals to 1 over 3 at x naught, y naught. Now we need to find fy at x naught, y naught. Fy means partial derivative of f with respect to y. We treat y as a variable and we treat x as a constant. To find fy, we differentiate from f equals to ln square root of 1 plus xy. Okay. To differentiate ln square root, we can write ln bracket to the power of half. Okay. And then using the properties of log, we can move power to the front. Okay. So we get half ln 1 plus xy. Okay. We can use y in different colors because now we want to find fy and we treat y as a variable. Okay. And from here, half is a constant and then ln 1 plus x with variable y here means we have function ln with variable y. Okay. So when we find fy means we differentiate f with respect to y. So we have this. Okay. Alright, from here we have multiplication between constant and function with variable y here. Okay. So when we differentiate, we just keep the constant in front. Okay. And then we differentiate the function with variable. So we get this. Okay. Alright, to differentiate ln 1 plus xy, we just imagine we want to differentiate ln 1 plus 3y. We assume x, which is constant, equals to 3. So now we want to differentiate ln 1 plus 3y with respect to y. So we get 1 over 1 plus 3y times, we differentiate the function inside ln. We differentiate 1 equals to 0. And then plus, we differentiate 3y with respect to y. So we get 3 here. So that's why when we differentiate 1 plus xy, we get 1 over 1 plus xy, okay, from here. And then times 0 plus 3 here means x. Alright. And after that, we simplify. So we get x in numerator over 2 times 1 plus xy. Okay. After that, we can find x at x naught, y naught. Okay. Alright. And then we replace x naught equals to 1 from the previous slide. Okay. From step 1, x naught equals to 1 and y naught equals to 2. Right. Then we can find the value of fy at x naught, y naught. So we get 1 over 2 and then 1 plus x we replace by 1 and then times 2. Okay, and then we simplify, so we get 1 over 6. Okay, we leave fy in fraction. Do not leave it in decimal for more precise approximation. Alright. Right, after that, we can continue with step 4. Use df equals to fx dx plus fy dy. Okay. So from df equals to fx dx plus fy dy. So from here, we have df equals to, we replace fx equals to 1 over 3. And then times dx. dx we get from the first step, which is equals to 0.1. And then plus fy. fy equals to 1 over 6. And then times dy. dy we get from the first step in the previous slide, which is equals to negative 0.02. Then we calculate, so we get df equals to 0.03. Alright. After that, step 5, we approximate the given value, okay, or the given function. So from here, we have f 1.10, 1.98, approximate to. Alright, the formula is f x naught y naught plus delta plus df. Okay. So for left hand side, we just write the given question or the function that we want to approximate. Okay. Or the expression that we want to approximate. Okay. Then we use approximate to fx naught y naught plus df. Alright, we find fx naught y naught in step 2, which is equals to ln sec 3. And then plus df. Okay, df from here. Okay. Then we calculate, so we get 0.579. Correct to 3 decimal places. Okay. This is the answer when we use total differential. We can check the answer, okay, from here. Okay. Using calculator, we can calculate ln square root of 1 plus, we replace x by 1.1 and then times, we replace y by 1.9. So when we use calculator, we get this answer 0.578, correct to 3 decimal places. If we compare, when we use total differential, the answer almost accurate, right? Coming up next, chain rule for partial derivatives. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.